All right, 5.6, find rational zeros. So we've got one note thing here. The rational zero theorem says if f of x is equal to a sub n x to the n plus dot 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 plus a sub 1 x plus a sub 0, so I just shortened it down, has integer coefficients then every rational zero of f has the following form. And so this is the part that you really need here. So plus or minus p over plus or minus q. And so the top is the factors of the constant term, a sub 0, so that would be the very last term, over the factors of the leading coefficient, which is that a sub n value. So it's the factors of the last term over the factors of the first term, assuming we are written in standard form. So the two different instructions you're going to see within this section are going to be to list all possible rational zeros and then find all real zeros. Those are going to kind of be like the two things. So when it asks you to list all possible, that would just be doing this. When we're finding the ones that basically actually work, which are the real zeros, we'll be using a slightly different method to do that. Like the setup will be the same, but the actual way we'll solve them will be different. So the first ones we're going to do is list all possible rational zeros. So we've got number 4, g of x is equal to x cubed minus 4x squared plus x minus 10. So I don't care about all the terms in the middle. All I care about is the first and the last term when I do this. I don't even care about what sign is on the first and the last term because everything is plus or minus when I do it. So this one is going to be last term over first term, so plus or minus 10 over plus or minus, there's a 1 in front of that, so plus or minus 1. And so the way that you do this, okay, is we set up like a little fraction bar. So I need factors of 10, okay, so plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So those would be the factors of that. And then on the bottom, it's just 1 in this case, so plus or minus 1. So then with this one, since there's a 1 on the bottom, you don't really have to do this part. But the next step after that is to write all of them out. So in this case, since it's a 1, it's not really going to look any different. But if it wasn't a 1, like in the next one, it'll be a little different. So plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. This would right here be the final of listing out all possible rational zeros. Number 6, h of x is equal to 2x cubed plus x squared minus x minus 18. So last term over first term, so this is going to be 18 over 2, plus or minus 18 over plus or minus 2. And I'm going to list out all of the factors of 18 in order, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Then on the bottom, I have a 2 this time, so it's plus or minus 1 and plus or minus 2. So now, when I go to write them all out, the first time I do it, I write all of these numbers over 1. Then the second time I do it, I write all of these numbers over 2. If there's any repeats, so like when I get to 2 over 2, that's going to reduce to 1. I'll already have 1 written. It doesn't get written again. It only gets written one time. So this would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Now the 1's over 2, so that's going to be plus or minus 1 over 2. 2 over 2 is just 1. I've already got that. Then plus or minus 3 over 2. 6 over 2 is 3, which I already have written, so I don't need that one. Then plus or minus 9 over 2. And then the last one, plus or minus 18 over 2, that would reduce to 9, so I don't need that one. So that would be all of them. So what this means is that based on what I have, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 possible zeros that this function could have, basically, that are real. There is an option to have complex zeros, but I don't think we do that in this class. We don't get to that till pre-cal, I don't think. Let's look at eight. F of x is equal to 3x to the 4th plus 5x cubed minus 3x plus 42. So what's my top number? 42. And what's the bottom number? 3. All right. This time I'm going to have y'all tell me what the zeros are, not the zeros, the factors are. So what are factors of 42? 2, 3. So now it's whatever it goes with. And then 3 is just 1 and 3. So I'm going to copy down all of the numbers first for the over 1 part. So I have all of those ones. So then I'm going to do them over 3. So obviously they're also plus or minus. I'm just not saying it because it gets to be a lot. So 1/3, 2/3. 3 over 3 is 1, which I already have. 6 over 3 is 2, which I already have. 7 over 3. 14 over 3. 21 over 3 is 7, and 42 over 3 is 14, I think. Yeah, so I don't need any other ones. So those are all of the possible ones. Any questions on finding all possible ones? Are we okay with that? All right, so the next thing then is finding all real zeros. So that means we take this a step farther. Okay, so you will need your calculators for the next part of this. So the initial first step will stay the same. So you get lots of practice of this part. The initial first step will stay the same, and then we'll need our calculators at that point. So number 12, we've got f of x is equal to x cubed minus 5x squared minus 22x plus 56. So take a second and list out all possible. So basically do what we just did and then pause, and we'll pick up there with what you need to do after that. And I'm going to tell you the ones that are over 1, so like the ones that are over 1, you don't have to write them as a fraction bar if you want. The ones that are over something other than just 1, you do need to do it. So that way you don't have to write them out so many times. All right, what numbers did we get when we wrote them out?
Well, plus or minus 1, 2, 4, 7, 8.
There's 2 in the middle you're missing there.
Here.
Anybody have the ones that she's missing after 8 before 56? 28 is one of them. And 14. All right, so that's the first step there. So now you're going to go on your calculator and you're going to go up here to y equals. And in this box, you are going, or in this box, in here, you're going to put this equation up here. So x cubed, in case you don't know, x is up here, and then you need it like cubed. It's the little caret button over here to the side. Minus 5x squared minus 22x plus 56. I have to get out of here for a second because I think I have my stat plots on. Nope, they're off. Okay, never mind. All right, after you have that typed in, you're going to hit zoom, which is up here, top middle. And then it's option 6, which is zoom standard. So that's how you graph just like a typical equation in your calculator. So zoom 6. Now, this is a cubic function, okay? That means that I should have 3 zeros. I can't have more than that, okay? Now, what you don't know yet, but you will, spoiler alert, is that sometimes some of those zeros are either double zeros, meaning like we have 2 at the same spot. We might have complex zeros, meaning they have i's in them. So you can have no more than 3, but this one does, in fact, have 3. So what I'm doing is I'm looking here, and I want to list out which ones I think might be potential actual zeros. Okay, so where they cross the x-axis. So I'm looking down here. So negative 1, 2, 3. So it looks like negative 4 might be an option. So I would write that one down because we're going to have to check them in a second. Over here, 1, 2. Looks like positive 2 might be an option. And then 3, 4, 5, 6. Positive 7 also looks like it could be an option. So you write those down and then we check them. Man down. Now, when we get to the ones that have the fractions and stuff, like these numbers up here, obviously it's going to get a little more dicey at times, and so you may, like this one, I'm pretty confident that these are right, but the ones up here, sometimes you have to kind of think through them a little bit and see which ones work, and sometimes you have some that don't end up working, just depending. So, I'm going to check these using synthetic. So I put each number in the box, and then I just run synthetic. If I get a 0 out at the end as the result, it was in fact a 0. Okay, so this is a little bit going back to 5.5 in terms of, we said like checking to see if something was a 0. Now we're combining 5.5 with this section. So 1, -5, -22, and positive 56. And don't forget, if there's ever a term missing, we still would have to put in a 0 just like normal. So bring down the 1. Got times -4. So I've got -4 minus 5 is -9. Times -4 is positive 36. Minus 22 is 14. Times -4 is -56. That produced a 0, so that one did in fact work. Now, if I wanted to make my life easier, I could just use this and factor on down that way, or you can use the original. It really doesn't matter, but I could do it this way. So 2, and then 1, -9, and 14, because eventually we'll get to where you'd want to do it this way. So bring down the 1, times 2 is 2, minus 9 is -7, times 2 is -14, and that's 0. So that produced one that worked as well. And then the last one, we put 7 in the box, got 1 and -7. Bring down the 1, times 7 is 7, minus 7 is 0, and so that one worked as well. And so all of those that I wrote down that I thought could work did in fact work. But if I didn't want to do this method of just like using the one that I had found to keep going, then I could have just used the original numbers every time. But eventually this will help us get to something we want to do in the future. If it had not resulted in a 0, it would not have been a 0. I would have wanted to put a slash through it up here, but they all were, so I don't have to worry about that. And you would have to start over at that step again in order to do it. You couldn't just like use the reduced form if there wasn't a 0 there. Let's do one more of these easier ones, and then tomorrow we'll do the ones that have a number in front. So these ones will all just be with a 1 in front so far. 18 g of x is equal to x to the 4th minus 16x squared minus 40x minus 25. So what do you initially notice knowing that I'm going to have to do synthetic at a point? Yep, we're missing the x cubed term. So I'm going to write that there just so that when I go to do my synthetic, I don't forget about it. I don't need that for the first part, but it'll be relevant later. So I'm going to have factors of 25 over factors of 1. So what are my factors of 25? So this is the first one we've had that's had an odd number of terms because obviously 5 times 5 is 25, but we only write it once. So now on your calculator in y equals, you will want to put this function. You don't have to worry about the 0 part here with this one. We don't need to worry about the 0 piece until synthetic. So clear that. So I've got x to the 4th minus 16x squared minus 40x minus 25. And then once you've got that, zoom 6 again. Now, how many times does it appear that it crosses here? 2. Okay, but how many could I potentially have? 4. So that either could mean that there's a double zero somewhere, or one of them might not be on my screen because this window only goes from -10 to +10, but as we work down, we'll be able to figure that out. Or I could have complex 0 in here as well somewhere. So what numbers does it look like might be possible zeros or potential ones? -1 and +5. So let's check those. So I'm going to start with -1. So -1. So I've got 1. I'm missing that x cubed term, so that's where that 0 comes in. -16, -40, and -25. Bring down the 1 times -1, so I've got -1 plus 0 is -1 times -1 is +1 minus 16 is -15 times -1 is +15 minus 40 is -25 times -1 is +25 minus 25 is 0. So that one worked. So then again, I'm going to use the reduced, or like the simplified one. So 5, then 1, -1, -15, -25. So bring down the 1, times 5 is 5, minus 1 is 4, times 5 is 20, minus 15 is 5, times 5 is 25, minus 25 is 0. So that one also works. So now you don't have to, all it asks us to do is this, but what you would be left with here is x squared plus 4x plus 5, and basically we would just be like writing out factors again of that, but we don't need to do anything with that. So the only two zeros that worked are -1 and 5. You can just disregard this. We don't need this piece of information for what we're doing right now. So, and that would be all that you have to do for those. So I'm going to go ahead and give you a couple. They're not due tomorrow, but just so that if you want to get started on them, because these can be a little time consuming. And then tomorrow we'll look at the ones that have numbers in front, which means that we'll be testing fractions and stuff like that, because fractions within synthetic can be a little bit of a pain sometimes. It's not hard, it's just, fractions. So the couple that I would give you to this point are 3, 9, 11, and 15. And then I'll add a few to it tomorrow from the harder stuff.